let's talk about our speaker a little bit. The green industry, as we know, is kind of I would say, a large family in a lot of ways. It's not the biggest industry in the world, but I will say that our presenter today is probably what I would call at this point one of the biggest rock stars of our industry. It's a big mantle to carry there, Doug's, but you are a person with the right information at the right time. He's currently a professor at the University of Delaware, and as he has been for the last 45 years. And he's in the Department of Entomology and Wildlife Ecology there. He's a best-selling author of five books, including Bringing Nature Home and Nature's Best Hope. He's the co-founder of Homegrown National Park, and he is the undisputed leader of the movement that has empowered all of us to use more native plants to bring life to the gardens and landscapes of our streets and towns by supporting native insects and wildlife. So we at American Beauties believe in his message and support it, and we are so proud to introduce today Dr. Doug Tallamy.
Well, thank you, Tim. That's what we're going to talk about. We're going to talk about getting more natives into the landscape, why we need to do that. Now, I typically am talking to the public, and every once in a while there's a nurseryman in the audience. Today's going to be the opposite. We got a good percentage of the audience involved with the nursery trade, horticultural trade. So I'm going to back up for a second and talk about some of the things I hope we can accomplish for nurserymen today. I want to help you market these things. You're not going to be able to do that if you don't truly understand why we need natives, why the public wants them today. The demand exceeds the supply. That's a business opportunity. And I firmly believe that they are the future of landscaping. So the nursery industry wants to be on top of that. First, let's define what a native is. It's one that co-evolved with the plants and animals around it. So it has an evolutionary history with the community that it's in. And with that definition, you can figure out which plants belong and which ones do not. So I call this nature's best hope. And I'm going to tell you what my idea of nature's best hope is. And I'll give you a spoiler, you're nature's best hope. So I'm really going to tell you about why I think so. But before I do that, let's talk about what E.O. Wilson's idea of nature's best hope is. He, of course, is no longer with us, but he was the most famous, I think, certainly the most famous entomologist Harvard has ever turned out. Conservationist, author, sociobiologist. Wilson did just about everything. But one of the things that was consistent throughout his very long career was his love of life on Earth and his efforts to save it. And he wanted to save it not just because he loved it, but because he knew it was essential to our own survival. So in 2016, he wrote this book, Half Earth, Our Planet's Fight for Life. And he had one simple message. He said, if we're going to save any life anywhere on planet Earth, we're going to have to save half of the planet for nature. We're going to have to save functioning ecosystems on at least half of the planet, or it will disappear everywhere. And that includes humans. It's a very bold statement. And he spent most of the book talking about the science that supports that very bold statement. And then he ended the book. He didn't spend a lot of time telling us how we were going to save nature on half of planet Earth. Of course, to a conservation biologist, that's a great idea. We'll just put half the Earth aside, and all those things that are in trouble can be in that half. We humans can be in the other half, and it'll be great. Problem is, half of terrestrial Earth is already in some form of agriculture. I don't see that diminishing anytime soon. And we got 8.4, I think now, 8.4 billion people in the other half, along with all of our hardscape roads, airports, detritus. And we don't have a third half to put aside for nature. So how can we realize E.O. Wilson's dream? That's really what I want to talk about today. And I think we can, but we need a new approach to conservation to do that. Before we talk about that, though, let's talk about what happens when we have an oak mast. Every once in a while, all the members of a particular oak group get together and decide to make their acorns at the same time. And this is what it looks like when that happens. I'm easily entertained. So I can take one of those acorns and I just stare at it. But often I'm rewarded because an insect starts to chew its way out of the acorn, First, it chews a little hole for its head, then it forces its head through there, then it forces its entire body through that hole. It's a tight squeeze. And once it's out of the acorn, it's a dangerous time for that insect larva because it's good to eat. A lot of things are after it. So it gets to safety by wiggling and squirming beneath the soil surface. That takes about 30 seconds. And once it's underground, it stretches in all directions and forms a chamber. And within that chamber, converts itself to a pupa and then surprisingly stays in that underground chamber as a pupa for 2 years. After 2 years, comes out as an acorn weevil. So an acorn weevil looks like. A lot of people think weevils have big noses because it looks like they do. But that's actually an extension of the head capsule, and the mouth parts are way down there at the end of that extension. They take those mouth parts and chew a hole into the center of the acorn, turn around, lay an egg in it, and that is how the larva gets into the acorn. Why do they spend 2 years underground? Why don't they come out the next year? Well, it takes red oak acorns in particular 18 months to complete their development. So if they come out the next year, there wouldn't be enough acorns for them. Of course, after they leave the acorn, it leaves a hole. It's kind of like a true vacuum, and you know that nature abhors a vacuum. And in this case, she's filled it with 3 species of temnothorax ants, tiny little ants where the entire colony lives in the holes made by acorn weevils after they have left the acorn. And when scouts find a new, well, they fill that vacuum with 3 species of temnothorax ants, tiny little ants where the entire colony lives in the holes made by acorn weevils. And if scouts find a new hole in a new acorn, they get all excited because their old acorn is falling apart. So they tell everybody it's time to move. Grab the larvae, grab the eggs, move the colony into the new acorn. That takes about 30 minutes. And once they're inside, they post a guard to make sure nobody else comes in. And that's where they'll live for the next 2 years until this acorn falls apart. And what's my point with that little story? That's just one of literally millions of very specialized interactions, largely between animals and plants, that comprise the bulk of nature. Nature is built from specialized relationships. This is one of those relationships, the relationship between jays and acorns. Jays are the primary disperser of oak acorns. They'll take an acorn, they'll fly up to a mile, sometimes a mile and a half from the parent tree. Then they tap it below the surface of the soil. And the object is going to go back in the wintertime and have something to eat. But for every 4 acorns they bury, they only remember where one is. So for every 4 acorns they bury, they've actually planted 3 oak trees. Specialized relationship between pileated woodpeckers and carpenter ants. That's what they rear their young on, carpenter ants. So you won't have pileated woodpeckers unless you have a lot of carpenter ants, and won't have a lot of carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have Phacelia. That is the only pollen that bee can rear its young on. And it turns out that pollen specialization is very common in our native bees. We got between 3,500 and 4,000 species of native bees, and over a third of them can only reproduce in the pollen of particular plants. You won't have the Baltimore checker spot unless you have white turtlehead. I could talk all day, all week, all year about nature's specialized relationships, but the point I want to make today is that many, actually most of these relationships are in trouble. Nature itself is on the ropes. And it's on the ropes because we didn't take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, looked out over the edge, and he said, leave it as it is. And with those 5 words, he started the process of creating the Grand Canyon National Park. Well, we didn't leave most of the lower 48 states as they were. There's only about 5% that's anything close to its original pristine ecological condition, and those are typically mountaintops. And that's because we have logged the country repeatedly, we have tilled it, we have drained it, we have grazed it. Got 770 million acres of rangeland out there. That's 4.5 times the size of Texas dedicated to cattle. And of course, we've paved it or otherwise developed it. We have straightened our rivers and dammed them. You can spell that any way you want. We've polluted our skies and changed our climate for centuries to come. We've drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we have carved up those natural areas into tiny remnants of their former selves. And each one of those remnants is too small and too isolated to sustain the amount of nature that we humans need. Because again, it is nature that keeps us alive on this planet. Edwin Way Teale decades ago said we cannot make the world uninhabitable for other forms of life and have it habitable for ourselves. It's just common sense. But that's what we're doing. That's what we've been doing. So why? Why are we doing that? Well, I don't know, but I suspect we thought that our nest, planet Earth, was so large we could foul it forever and there wouldn't be any consequences. But of course, we were wrong about that. That's why we're seeing some scary headlines these days, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Followed by this one, North America's lost 3 billion breeding birds in the last 50 years. That's a third of our North American bird population already gone. Now, the UN is predicting we're going to lose 1 million species to extinction in the next 20 years. And they made that prediction 3 years ago, I think. So maybe that's now the next 17 years. It's a prediction, hasn't happened yet. And we have to make very sure that it doesn't happen because those are the species that run the ecosystems that we all depend on. So it's serious business. Now, I could go on talking about the pox that we humans have delivered upon the environment, as Shakespeare would say, upon all of our houses. But that's not what this talks about. This talks about a cure for that pox. It's a cure that'll take small efforts from lots of people, people like you and me, but those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, back to E.O. Wilson. He told us what would happen if insects were to disappear, and he did it way back in 1987 with this paper, The Little Things That Run the World. And again, his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, it would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our vertebrate animals would collapse. We would lose our amphibians, our reptiles, our birds, and our mammals. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And again, humans wouldn't survive any of those drastic changes. Now, there is good news, and that is that none of that has to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape to do it. Why is that? Well, remember, humans are products of nature. We are totally dependent on the life support that ecosystems provide. We call them ecosystem services. These are just a few things that plants do every day that we depend on every day, like oxygen. Plants are producing that oxygen. They're cleaning our water, slowing its journey to the sea where it becomes too salty to use. Carbon capture, enormously important today. Plants, of course, build their tissues out of the carbon dioxide that's in the atmosphere. They fix that carbon through photosynthesis, and then they pump the extra carbon that they fix into the ground through their root systems. And once it's in the ground, it's extremely stable. It's out of harm's way. Plants are building topsoil. They're holding it in place. They're preventing floods. They're dampening severe weather. They're converting sunlight into food. You know, if we lose our plants, we're going to have to eat sunlight, and then we will lose weight. What are animals doing for plants? They're providing pest control services. They're pollinating nearly 90% of our flowering plants. They're dispersing plant seeds. So designing landscapes like this that destroy the production of ecosystem services is just not a good idea. Never was a good idea, but today it's a terrible idea because of those 8.4 billion people that are demanding more and more ecosystem services every day, not fewer and fewer. Now, we do have parks, we do have preserves, and they're doing the best they can, but we are approaching the sixth great extinction event the planet has ever experienced, which means it's not good enough. So I think the answer is to start to practice conservation outside of parks and preserves on landscapes just like this. There have been visionaries through the ages who've recognized that we humans needed to work on our relationship with planet Earth, and Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s. One of the things he said is the oldest task in human history is to live in a piece of land without spoiling it. There have been indigenous groups been able to do that for long periods, but our huge Western societies and our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, going to another area, doing the same thing, not sustainable behavior. But Aldo Leopold had a lot of faith in humans. He believed we were capable of developing what he called a land ethic. He knew we had to use the land. We had to farm and lumber and graze and mine and do all of those things. But he believed we could learn to do them gently enough that we did not destroy local ecosystems. That's what he called a land ethic, recognizing that humans are part of the ecosystem, not there just to exploit it. And he wrote about the land ethic in his most famous book, The Sand County Almanac. What he did not write about, though, was developing a land ethic where we actually lived. And I'm not sure why that was, but I suspect the notion that humans and nature cannot live together. We cannot coexist in the same place at the same time. That notion was so deeply embedded in the culture of Aldo Leopold's day, still remains in our own culture, that he may not have recognized it as an option. What I want to argue today, though, is not only is living with nature an option, it is now the only viable option that's left to us. In the past, of course, conservationists worked pretty much exclusively where there weren't a lot of people. We now need to turn that on its head and practice conservation where there are a lot of people, because that's pretty much everywhere. And that means we've got to find ways for nature to thrive in human dominated landscapes, not hang on by a thread, not get diminished every day, but thrive. So, where are we going to start? We're going to start on private property because most of the country is privately owned. Almost 80% of the lower 48 states is privately owned. 85.6% of the U.S. east of the Mississippi is privately owned. If we don't practice conservation on private property, we're going to fail. And failure, by the way, is not an option. Now, when I use the word conservation, I'm not using it exactly the way I mean. We do want to conserve any bits of nature that are left out there. That's been our conservation model for the last century, and we do want to keep doing that. But it's obviously not enough. I mean, we're in trouble because it's not enough. So we have to go beyond conservation into restoration. We've got to rebuild nature in as many places as we possibly can. And you might be thinking, there's no way you're going to put it back together again exactly the way it was. And you're probably right. We've changed too many things. But we can reunite enough of those specialized interactions that I opened the talk with to form ecosystem function again, even if it's not exactly what was on a particular space at some point in the past. But in order for this to succeed, we have to start with the building blocks. Not all species contribute to ecosystem function equally. So we have to start with the most effective groups. And there's two groups we can't do without. One is the flowering plants, and of course, the pollinators that allow those plants to reproduce. They're capturing energy from the sun and through photosynthesis, turning it into the simple sugars and carbohydrates, which is the food that supports just about all the animals on the planet. So now we have the food that animals need locked up in plant tissues, mostly leaves. If we don't get that food to animals, you don't have any animals. And if you don't have any animals, you don't have a functioning ecosystem. Well, it turns out that most vertebrates don't eat plants directly. Most vertebrates eat invertebrates that ate those plants. And most of those invertebrates are insects, but not just any insect. It turns out that caterpillars are enormously important in terms of transferring energy from plants to other animals. They are transferring more energy from plants to other animals than any other type of plant eater. And that's why Dan Jansen calls them the meat and potatoes of terrestrial food webs. So if we design landscapes that don't have a lot of caterpillars in them, we're going to have failed food webs and eventually failed ecosystems. And I'm going to use the Carolina chickadee as an example, but it's just an example. Most of the birds out there do exactly what the chickadee does. This is the chickadee that is coming to my feeder right here in Oxford, Pennsylvania. But there are several species of chickadees around the country, and they all go to feeders and they eat seeds. And we tend to think that that's what chickadees need, seeds. Well, 50% of their diet in the wintertime is seeds, but 50% isn't. It's insects and spiders. And when it comes time to reproduce, their babies can't eat seeds at all. And again, that's true for most birds. Babies cannot eat seeds, so they switch to invertebrates. And if they're in a healthy environment, they will rear their young exclusively on caterpillars. And they are not alone. 96% of our terrestrial birds rear their young on insects, and most of those insects are caterpillars. So there's something special about caterpillars. We need to understand what that is. There's several things special about caterpillars, and one of them is that they're soft. So think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is exoskeleton. It's made of cuticle, made of chitin, indigestible. And because they're soft, you can stuff them down the throat of your offspring without fear of injuring them. And if you've ever watched a parent bird rear their young, they're pretty rough. The beak's like a plunger. They just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our smaller birds do chase aphids around, but you want to chase 200 aphids or get one caterpillar. They're nutritious. They're very high in fat, very high in protein, low percentage of chitin, of exoskeleton compared to most other insects, particularly beetles. Beetles are not like little sausages. They're like little tanks. So much of a beetle is undigestible, and many beetles have really sharp edges too. And finally, it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. And I mention carotenoids not because I love organic chemistry, but because I'm a vertebrate. You're a vertebrate, and birds are vertebrates. And we vertebrates can't make our own carotenoids. Only plants make carotenoids, so we have to get our carotenoids from plants, and we have to get them from plants because carotenoids are essential components of vertebrate diets. Where are the birds getting their carotenoids from, particularly during the breeding season? Well, from all those prey items they bring back to the nest. But look, carotenoid content is not equally distributed among bird prey. These first two bars here are types of caterpillars, and they have far more carotenoids than the other types of bird prey. Here are the adult caterpillars. Here, the moths and butterflies themselves. They have far fewer carotenoids because they're not eating the green leaves. That's where the carotenoids are. And here's the earthworm way over here. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. So that study and others are suggesting that for most birds, caterpillars are not optional parts of the diet. They are essential parts of the diet. So let's just say most birds need caterpillars. The next question is, how many caterpillars do they need? Is one or two enough? Or one or two a day enough? It's a good question. So let's go back to the Carolina chickadee. There's a lot of data on Carolina chickadee. How many caterpillars does it take to make a nest of Carolina chickadees? One or two is not enough. One or two a day is not enough. It takes thousands, 6,000 to 9,000 caterpillars to get one clutch of chickadees to the point where they leave the nest, depending on the number of chicks in the nest. And after they leave the nest, the parents continue to feed them caterpillars another 21 days. But they're flying all around, so nobody's been able to count the number of caterpillars required. But you're really talking about tens of thousands of caterpillars required to make a bird that's a third of an ounce. That's 4 pennies worth of bird. And if you want chickadees to breed in your yard, and I would think you do, you have to have all those caterpillars in your yard because chickadees only forage about 50 meters from the nest. And that's true for most birds. They forage very close to the nest. And if we landscape in a way that does not include all of those caterpillars, that's called insect decline. And it's really looking like bird declines are related to those insect declines. We went to the original data set of Rosenberg et al. That's the Smithsonian group that said we've lost 3 billion breeding birds in the last 50 years. And we divided the terrestrial bird species into two groups, the species that require insects, particularly when they're breeding, and the species that do not require insects. So things like finches and doves and crossbills can actually make a little milk out of the seeds that they eat, and they can rear their young on that. And look, the birds that do not require insects didn't lose any numbers in the last 50 years. But the ones that require insects lost on average 10 million individuals per species. This does not prove cause and effect, but it does suggest that as you take bird food away, you lose the birds. So I think we need to raise the bar about what we're asking our landscapes to do. In the past, we've asked them to do one thing, be pretty. Now we're going to ask them to do two things, be pretty and ecologically functional at the same time. And that's not going to happen unless you put the caterpillars back in that landscape. So how do you do that? How do you add caterpillars? You add them by adding the plants that support those caterpillars. It seems pretty straightforward, but there is a catch, and that is that most plants do not support a lot of caterpillars. So we have to be fussy about which ones we put in our landscapes, and we have to be fussy about it because the caterpillars themselves are fussy about it. And the monarch butterfly illustrates that perfectly. You can have all the crepe myrtle and all the ginkgo and all the hostas and all the burning bush and all the privet, all the stuff that we typically landscape with in your yard, and you won't make a single monarch butterfly. The only thing that's going to make a new monarch butterfly is one of the milkweeds. That's called host plant specialization, and it turns out that most of the insects that eat plants are host plant specialists. They can only eat particular plants, the plants for which they have very specialized adaptations. Why is that? Well, remember, plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world, which is why it's green out there in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. But insects do eat plants. So how do they do that? How do they get around those chemical defenses? This is where the specialization comes in. 90% of the insects that eat plants can only eat the plants for which they have those specialized adaptations. They have enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize the insect's exposure to those compounds. But it takes a long period of interacting with all those plant lineages for those adaptations to fall into place. And once they do, the insect is locked into eating that particular plant. So if you take the milkweeds out of your yard and replace them with hostas, the monarch's not going to start to make a living on hostas. It's locked into eating milkweeds. So it has two choices then: fly away and find milkweed someplace else or starve to death. It's actually very simple. There are three kinds of plants out there: plants that contribute energy to local food webs, plants that do not contribute energy to local food webs, and plants that remove energy from local food webs. The very best contributor in 84% of the counties in which they occur is one of our oaks. Oaks are contributing more energy to local food webs than any other plant genus by far. A good example of a non-contributor would be a ginkgo, Ginkgo biloba from Asia. It's a good ornamental plant, has good fall color, but nothing eats a ginkgo. So it's capturing energy from the sun, but it's not passing it on to anything else. And a good example of a detractor would be any of the invasive ornamentals that are not passing on their energy, but they're also not staying where we plant them. Things like Callery pear, Bradford pear. This is what a typical invasion looks like. We have measured caterpillar populations in plant invasions like this. And there is a reduction on average of about 96% of the caterpillar biomass. So if you're thinking of caterpillars as bird food, you've reduced bird food availability by 96% when you have a plant invasion like this. And let's face it, we've got plant invasions like this all over the country. All I'm trying to say here is that plant choice matters. We cannot rebuild ecosystems if we don't have functional food webs in those ecosystems. And you're not going to have functional food webs unless you plant the plants that support those food webs. And I'm going to give you three examples of how well this works when you do plant the right plants. I'm going to start with what's happened at our house where my wife Cindy and I live. We moved into a 10-acre lot. It was part of a farm that was broken up in the year 2000 into 10-acre lots. We got one of those lots. Very old farm. It farmed almost 300 years, and the last thing they did was mow it for hay. So very little, very few plants there. And our dream, our goal was to restore the eastern deciduous ecosystem that was once here, which we had never done. We didn't know what we were doing. And one of the things I wanted to try, though, was to plant the host plant of a particular species of caterpillar, of moth, and see whether it actually came. See if I could add species to this property. And the first one I tried was the Canadian owlet. I'd never even seen a Canadian owlet before. Pretty little thing. The adult looks just like a leaf. Well, you're not going to have Canadian owlets unless you have their host plant, which is meadow rue, host plant specialization. And we didn't have any meadow rue. I'm sure it was there 300 years ago before the area was farmed to death, but the meadow rue was long gone. So I got some meadow rue seeds from someplace. I planted them. They grew very nicely. But this was early on, and I actually had very little faith that Canadian owlets would appear out of nowhere and colonize my little patch of meadow rue. So I didn't even go out and check it for at least 2, 3 months after I planted it. And then I walked by for another reason, and they were covered with Canadian owlets. They had found it right away. I'm still impressed with that. So we've added two species. We've got a good population of Canadian owlets and a good population of meadow rue, two species on our property that didn't used to be there. Same story with the goldenrod stowaway. That's actually a misnomer. This beautiful moth has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa, ditch daisy. We didn't have any Biden's aristosa, but I did know where there was some Bidens in a power line cut about 14 miles away. So I got some seeds, planted them at home. They grew very nicely. As a matter of fact, last year they took over my front yard. That's okay. I had to wait a year for the goldenrod stowaway to find my patch of Bidens, but they did, and now we've got a good population of both of those. So we've added 4 species to the property. Want to see if the hackberry emperor could make a living at our house, not because it's the most beautiful butterfly in the world, but because it belongs there. It's one of the species that ought to be on our property. Well, as its name suggests, it's a specialist on hackberry, on Celtis. We didn't have any hackberry. So I got some hackberry trees, planted them. I had to wait 4 years for the hackberry emperor to find my hackberry trees, but they did, and now we've got a good population of them. So we've added 6 species, and that's how the restoration proceeded. I did not plant goldenrod, came in on its own. Along with it came many of the things that require goldenrod, like the beautiful brown-hooded owlet, the Arcidra flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. Goldenrod in the mid-Atlantic states supports 110 species of caterpillars. It's a very powerful plant. I planted Virginia creeper. Yes, Virginia creeper. I hear some people don't like it, but I don't know why. It's a great native plant. It's got good fall color. Where's my pointer? Good fall color. It can climb our trees without girdling them, without pulling them down. It's a good ground cover. It makes valuable berries for the birds in the fall. And by valuable, I mean they are high in fat. Our migrating birds need sources of fat to fuel that migration, and our overwintering birds need sources of fat to help them get through the winter. And those berries come from tiny little inconspicuous flowers you don't even know when Virginia creeper's in bloom until you see a big cloud of native bees around it. Turns out it's a wonderful pollinator plant. So remember, when you're making a pollinator garden, you're making it for the pollinators. If it's not big and showy for you, that's okay. I planted Virginia creeper because it's the best source of host plant for the large sphinx moths that are a primary component of cardinal diets. This is the Pandora sphinx on Virginia creeper. That's its beautiful adult. The lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. Want to see if I get the evening primrose moth to make a living in our house because it's beautiful. I like beauty like anybody else. Well, as its name suggests, it requires evening primrose, and we didn't have any, so I planted that, and it worked. The moth came, spends the day with its head stuffed in the flowers. Sometimes it's crowded, but it's always very cute. And I planted lots of oaks. Now, these are just examples of the plant lineages we put back on our property. But I want to focus on oaks for a while because they are such important plants. This is the Bedford oak in Bedford, New York, Martha Stewart land. People argue about whether it's 400 years old or 500 years old. It's enormous. And I hear people say, I'm not going to plant an oak because I won't live long enough to enjoy it. And if you can only enjoy your oak when it's 400 years old, you're right, you won't. But if you can enjoy what your oak is contributing to your local food web, you can enjoy it right away. And I can say that with conviction because I planted most of my oaks as acorns, which means they were free, or 2-foot bare root whips, which means they cost $1.50 each. And immediately they started to call in the moths that create the caterpillars that run the food web at my house. So things like the solitary oak leaf miner, Juvenal's dusky wing, the yellow-shouldered moth, Suzuki's promolactus, the red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the pink-striped oakworm, the hesitant dagger moth, the lesser oak dagger moth, the medium dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crowned bucolatrix, the orange-patched smoky wing, the white-blotched heterocampa, the oblique heterocampa, the red-lined panapoda, the laugher, and literally hundreds more species of caterpillars have come to the oaks on our property, and they come right away. This is a pin oak. It's just popped its head above the leaves, and there's a caterpillar standing on the ground eating the leaves of that tree. People say, oh no, it's going to kill the tree. No, an ovenbird's going to come eat it in the next 20 minutes. So this little first year seedling has already contributed to the food web. You don't have to wait 10 years or hundreds of years for your oak to start to contribute. It will contribute right away. Now, this is what our property looks like in the summertime, taken from pretty much the same place I took that first picture. Just to give you an idea, we have put at least some of the plants back. And the question is, does this work? Has life returned? Now, you can measure life any way you want. I'm measuring it in terms of the number of bird species that have nested on our property and the number of moth species that I have taken pictures of. And I am still at it, still counting those moth species, but I'm up to 1,366 species that I have photographed on our property, and they are there because I put their host plant back. Now we have 10 acres. Pennsylvania's 22.9 million acres, something like that. So on one tiny, tiny, tiny sliver of Pennsylvania, we've got 44% of all the moths that occur in the entire state. And because so many of those moths are types of bird food, we've recorded 62 species of birds that have bred on our 10 acres. Not flew by, but bred. Why am I telling you this? Well, this is another headline you see all the time. The World Wildlife Fund says Earth has lost 2/3 of its wildlife since 1970. It's a terrible statistic. But I'm thinking, gee, not at our house. I'm convinced we have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody put the plants back? We really could turn this around. But will it work on smaller properties, let's say in suburbia? It's an excellent question. So let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri. They have what I have, zero point 0.6 acres, 18 times less land than Cindy and I have. They're in the middle of a development. They're surrounded by everybody with the big lawns. When they moved into their property, it was choked with Amur honeysuckle, bush honeysuckle. So the first thing they had to do was get rid of that. Then they planted 70 species of native plants, added a water feature that they call a bubbler. And then they started to record all the birds using their property. They're still at it, but they're up to 154 bird species, including an amazing 35 warbler species. Just to put that in perspective, we've only recorded 18 warbler species at our house. So, does it work on smaller properties? Yes, it does. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago because her property abuts O'Hare Airport. Pam has 1/10 of an acre, 3 times smaller than the average lot size in North America. She's not connected to any natural area at all. So she's a tiny island in the middle of Chicago. It's a pretty island because Pam is a native plant landscaper and she knows what she's doing. But she did the same thing. She removed her non-native plants, put in 60 species of native plants, including a water feature, and then she sat back, she says, with a glass of wine, and started to count the birds that are using her yard. And she's up to 127 species that have used her yard, including a woodcock. There's Pam's woodcock. So if you haven't seen a woodcock lately, go to Pam's house in Chicago. All right, there's 4 things we need to do if we're going to succeed in a big way. And we need to succeed in a big way. And one of those is to address those big lawns that are out there. We've got 44 million acres of lawn nationwide. That is an area bigger than all of New England combined, dedicated to an ecological deadscape. Why do we do that? Well, lawn is a status symbol. It's a very important status symbol. We also like neat, and lawn is easy to keep neat. You sit on that mower and away you go. And we need to display our Halloween decorations. But remember, there are 4 ecological responsibilities that every landscape has. Every landscape needs to support a food web. Without a food web, you don't have a functioning ecosystem. Every landscape needs to sequester carbon to help climate change. Every landscape needs to manage the watershed in which it lies. And every landscape needs to support pollinators. Lawn does none of those things, which is why I pick on it. There's a pretty picture of phlox. And I can't remember why I have it in there, but we can enjoy it. That's what my backyard looks like. What if we were to cut the area of lawn in half? So let's make the math simple. Let's say we've got 40 million acres and we're going to cut that in half. That'll give us 20 million acres. We're going to take areas that look like this and we're going to convert them. We're going to restore them. So 20 million acres, how big is that? We're going to restore this right at home. That's an area bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. This is what we're going to create Homegrown National Park out of. So Homegrown National Park will be the biggest park in the country. It's a real thing. We're a small nonprofit. You go to our website, homegrownnationalpark.org, and register your property on the biodiversity map. And all that means is you put down where you are, your place, and the amount of area that you're pledging or already are being a good steward of on your property. Maybe you really are going to reduce the area of lawn. Maybe you're going to buy some American Beauties and put them in different places around your property. Maybe you're going to plant an oak tree. Doesn't matter what it is you're planning to do, but you put that area in the database, and then your little piece of your county is going to light up with a firefly. That's our emblem. And you get to see how many other people in your county have joined Homegrown National Park. And of course, the goal is to get the entire country to light up with fireflies. Our vision is very simple. We're envisioning a world where the restoration and protection of native habitats is mainstream. It's the default behavior of everybody that's out there, every organization that's out there. If you plant native plants, you're not going to be the kook down the street. You're going to be mainstream. That's our vision. There are real ecological products associated with Homegrown National Park. One is a significant increase in biodiversity, and what's happened at my house convinces me this can happen anywhere. Nature's really resilient. All we have to do is give her a chance. Measurable reduction in invasive species. If we remove the invasive plants just on our property, we'd be 80% done in the lower 48 states. 85% done in the east of the Mississippi. Not completely done, but it's a very good first step. Significant drawdown of atmospheric CO2. If you have a planting like this, you're going to sequester a whole lot more planting than lawn. Lawn is the worst plant for sequestering carbon. And we're also going to start to build viable habitat outside of viable habitat. So any bit of conservation we do outside of a park or preserve is going to help conservation inside of that park. There are also real sociological products associated with Homegrown National Park, and one is national awareness, not just of what the problems are, but what the solutions are and what our roles in those solutions are. We're trying to change the culture. We want people to recognize that nature's not optional. It's not just there for our entertainment. It's essential, and it's essential to everybody, which means everybody owns responsibility for sustaining it. We want to convert hope into action. Hope is good, but action's even better. We want to merge existing conservation organizations like Audubon, National Wildlife Federation, Wild Ones, all the land conservancies. They're doing wonderful conservation on private property, but nobody's measuring that. So we want to get all of them recorded on the biodiversity map so we can see how we're doing. Did I mention that Homegrown National Park is free? We're not trying to pull membership away from some other organization, but if you belong to another organization, you also belong to Homegrown National Park. We just need you to register that good conservation you're doing at home. Okay, we're going to reduce the lawn. What plants should we put in the area that was once lawn? I'm going to argue that some of them have to be what I'm calling keystone plants. Remember what a keystone is. It's the stone in the middle of the Roman arch. If you take that stone out of the arch collapses. Well, if you take keystone plants out of the local food web, the food web collapses because they are making most of the food. Just 14% of our native plants are supporting 90% of the caterpillar food that drives those food webs. So think of the keystone plants in the ecological house that you're building as the 2x4s that hold that house up. They are essential. They're the support system. You cannot build a house out of wallpaper, and that's what we've been trying to do for the last century. I mentioned oaks are the best keystone plant wherever they occur in the country. About 557 species supported in the mid-Atlantic states, over 1,000 species of caterpillars supported on oaks nationwide. Again, no other plant comes close to that. But wherever you live, you can go to Native Plant Finder and the National Wildlife Federation website, put in your zip code, and the ranked list of the most important woody and herbaceous plant genera in your county will pop up. And these are really abbreviated lists. I just ran out of room. The point is, what the genus that's going to produce the most productive plants where you live, all that information is right there in Native Plant Finder. So you don't have to wonder what it is you need to plant anymore. So we're going to reduce the lawn. We're going to put in native plants, keystone plants. We're going to invite a lot of insects to our yard, and then we're going to kill them with our security light, which of course is not the goal. Turns out that light pollution is one of the major causes of insect decline around the world, really. These are all the ways that lights are killing our nocturnal insects, particularly the moths that make those caterpillars that run our food web. So it is a really serious environmental issue, but fortunately, it has a really simple solution. First of all, you are allowed to turn your light out. It's okay. And if you're worried about security, put a motion sensor on it so that it only turns on when the bad man does come. Oops, sorry. That's my daughter calling. It's only going to turn on when the bad man comes. Even simpler is to take the white bulb out of your security light and put in a yellow bulb. You can go to the hardware store. They're called bug lights. They come in LEDs and incandescent lights. It looks like, they're selling them so they can kill your bugs, but no, it actually saves them because nocturnal insects are not attracted to yellow wavelengths. So if we were to switch out our white bulbs for yellow bulbs overnight, we would save millions of insects. And if we use LEDs, we would save millions of dollars as well. So we are going to shrink the lawn. We are going to use keystone plants. We're going to modify our lights, and then we're going to invite Mosquito Joe to come kill all of our insects. True. Natural and organic, maybe it's pyrethroids. It's the same compound made by chrysanthemums, but of course it's industrial strength pyrethroids. But cyanide is a natural organic product, and ricin is a natural organic product. So being natural and organic doesn't make it safe. They also say it only kills mosquitoes. That's not even close to true. It kills all the insects it comes in contact with. I did a study last summer with an undergraduate. Yeah, it kills monarchs. That's a product of a fogging event on Kent Island in the Chesapeake. We tested 29 species of insects, kills everything, even 30 days after a fogging event. Um, so the interesting thing is it doesn't really control mosquitoes. Kills about 40% of them. So you get 60% that are going to come back and get you. Try mosquito dunks. Get a bucket and fill it full of water. Put in a handful of straw or hay. Put it out in the sun for a couple of days, and that builds up populations of diatoms and algae. And that is what mosquito larvae eat. So female mosquitoes in your yard will lay their eggs preferentially in your bucket. Then you go to the hardware store and you buy a sheet of mosquito dunks. That is Bacillus thuringiensis, which is a natural bacterium that only kills aquatic diptera. And the only aquatic diptera in your bucket is mosquito larvae. So it's targeted. You're only killing what you want to kill. And it's cheap. This is $12 for a season's worth of control. If everybody did it, it really would work. Okay, the fourth thing we need to think about is how to landscape under those keystone plants that we put in our yard. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. Now, a few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from one of the branches, then it emerges as an adult, then it does it all over again. Everything happens on the tree. And I wish everything did that, but most species don't. Most species drop from the tree and wiggle their way under the ground and pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. We don't have any leaf litter under the tree. We don't tolerate it. We think it's messy, and we mow and compact the area under the tree so that it's rock hard, makes it very difficult for those caterpillars to get underground. These are oak trees. So they become ecological traps. They're calling in the moths to lay the eggs. Caterpillars develop, fall down, and die. And of course, the cement landscape is not the answer either. Now, this is what most people do. You've got a tree in a yard. Emma Jonas, my master's student who graduated last year, has measured how well caterpillars do in a situation like that versus a situation like this. And obviously, they do a whole lot better in a situation like this. This is called soft landing. That's what Heather Holm and Rebecca McCracken call it. Caterpillars fall down, and it's not just that it gives them a soft landing. It's that nobody's walking here. This is a no-go zone. So the ground is not compacted. There is leaf litter in here, and the caterpillars have everything they need to complete their development. This is where we can use those American Beauties. We can use all of our spring ephemerals, build all kinds of beds around your trees. So produces a safe zone for the caterpillars. The trees will love it. You're using green mulch. That's the way to go. Our classic ground covers like wild ginger, or this is native pachysandra. There's Virginia creeper as a ground cover, golden seal, mayapple, foam flower. Again, if you can see the ground, you don't have enough plants. Green mulch is the way to go, and the caterpillars will love it. Can we use native plants in formal designs? Of course we can. This is a Lynn O'Shaughnessy design taken by a drone 400 feet up. Every plant in that landscape is a native plant. You don't get more formal than that. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe every day. And they love them over there. So if they can love our native plants, maybe we can as well. Can we get a pollinator garden into a suburban landscape like this without offending anybody? Sure, we can. Just put a little fence around it. It formalizes it. It tells your neighbor that this is intentional. It's not just a bunch of weeds you forgot to mow. It's pretty when it's in bloom. It's meeting the needs of several species of bees. It's not, excuse me, they're not very big. Could be bigger. But if everybody did it, it would help a lot. Help what? Help support pollinators. Why do we need pollinators? Well, the media will tell you we need pollinators because they pollinate a third of our crops. It's actually about a twelfth of our crops. And I hear people say, well, I don't live next to a farm, so I don't need any pollinators. Forget the crop argument. We need pollinators because they're pollinating 80% of all plants and 90% of all flowering plants. Where do we need pollinators? Everywhere we need plants, which is everywhere. How about this? Drew Latham design, much bigger. Imagine the amount of life supported here versus the amount of life supported here. Seems like a no-brainer. And I think we've made three missteps in the early years of conservation. And the first one's really serious. We're starting to think of nature as if it's optional. It's not that we don't like it. We do like nature. We like to go bird watching or just take a walk in the woods, but we don't think it's essential. And if we don't think it's essential, when push comes to shove, when resources are in short supply, nature takes a back seat. And of course, resources are always in short supply. I went to the Cincinnati Zoo before the COVID virus broke out, and there's this wall-sized poster there, which to me epitomizes our society's view of conservation. We want to save nature, save wildlife, so that future generations can enjoy it. And I get that because nature is enormously entertaining, but it is much more than that. I mean, that was Teddy Roosevelt's argument for expanding the national park system. They're beautiful places, so we want to save them for future generations. They are much more than that. We want to save them so that we have future generations. We've also assumed that humans and nature cannot coexist. We talked about this, but if we restrict conservation just to the places where there's not a lot of humans, we're going to fail because those places are now too small, there's too few of them, and they're too isolated. David Quammen has a wonderful analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, none of which are acting like a Persian rug. And that is what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I don't like that language because it suggests there's places on planet Earth with no ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our corporate landscapes, including our roadsides, even including much of our agriculture. So we need to glue our rug back together again, folks. We've got to put the plants back, not just to make biological corridors that connect viable habitat with each other, but to restore viable habitat in all those places that we have destroyed it. The good news is it's starting to happen. It really is starting to happen. And when it does, it'll be the first time in modern history that humans have coexisted with the natural world. Our third misstep is to leave Earth stewardship to just a few specialists, few conservation biologists, few ecologists. For some reason, we didn't see it as an inherent responsibility of everybody on the planet, but I don't know why. Since every single person on the planet depends entirely on the quality of local ecosystems. So why wouldn't everybody bear the responsibility of taking care of those ecosystems? That doesn't mean you have to save biodiversity for a living, but you can save it where you live. And if you do, it empowers you. More and more people are concerned about the state of the planet, but they feel powerless. What can one person do? Well, one person can do a whole bunch. One person can shrink the lawn. One person can fire Mosquito Joe. One person can pull out their invasives. One person can put in a pollinator garden. One person can, what did I say, reduce the lawn, do all those things we just talked about. One person can buy American Beauties. And then you can help enhance your local ecosystem instead of continuing to degrade it. And it also shrinks the problem down to something that's manageable for each one of us. Don't think about the entire planet's problems. You get depressed. Just worry about the piece of the earth that you can influence. If you own property, it's obvious that's where you start. If you don't own property, help somebody who does. Help a land conservancy, help a park or preserve. They're all under staffed, underfunded. They will love you as a volunteer. Otto Leopold said, one of the penalties of an ecological education is that one lives alone in a world of wounds. And he said that in the 40s, and he was alone in a world of wounds. But you're no longer alone, folks. Everywhere, people are starting to heal the wounds on their little piece of the earth, and you can as well. Robert Swan once said, the greatest threat to our planet is believing that someone else will save it. It's not going to be someone else. It's going to be you folks because you are nature's best hope. Now let's address some of those questions that I know I'm going to get. The nursery industry has trouble selling local ecotypes. How important is that? It's important. You want to do the best you can with getting local seed sources. There's probably a lot more flexibility into it than you've heard. The farther away you get from sourcing a plant from your ecoregion, the more its ecological function is going to decrease. So obviously, getting plants from the Rocky Mountains and planting them in Delaware is not the way to go. But we do want to improve our ability to sell local ecotypes as best we can. How can we market these things? You know, the public is asking for native plants now. The demand exceeds the supply, so it's an easier sell than it was just a few years ago. But I don't know. I'm not a marketer. But how about these for some slogans? Plant for life, plant native. I mean, you are supporting life with natives a whole lot better than with non-natives. If you want birds, you got to have native plants. If you want butterflies, you've got to have native plants. If you want to support the food web, do those four things that every landscape has a responsibility for. Support the food web, help pollinators, fight climate change, manage your watershed. You've got to plant native. And then finally, natives are the future of landscaping. Any of those with little signs around your nurseries might help. Okay, I think that's all I have. I'm happy to take questions if you have any.
Oh, I've been accumulating, Doug, for you, so don't you worry about that. So,
Okay.
um, a couple of questions. If what is the first step that you would take in a home landscape to support native insects?
The first thing I would do is look at how much lawn I have and say, how can I reduce that lawn? Because reducing it with the appropriate plants is going to help all those things I just mentioned. It's going to, excuse me, it's going to create that food web. It's going to manage the watershed. It's going to sequester carbon. All kinds of great things that the lawn doesn't do. So, how would you do that? It depends on where you live. But if trees are appropriate, I would put in one of the powerhouse trees and then put a bed underneath it with your herbaceous plants to create those soft landings. That puts a lot of plant material into your yard. It's a relatively small space, so it's not going to break the bank. Those trees and beds will grow, and it also shrinks the lawn at the same time. So you can do that. Do one of those a year, and you can help to pick at the problem.
Uh, Oaks are very important, and we've had a couple questions on oaks. Uh, one uh, one uh, One viewer, Dorothy, was worried about losing that oaks might be being lost on her property. Have you seen that there's any issue out there with oaks? Why would that be happening? And if oaks just don't suit her, what are other a similar kind of keystone trees to replace them with?
Okay, well, yes, we have introduced at least three important oak diseases. We've got sudden oak death syndrome. We've got bacterial leaf scorch, which is more hitting the red oak group in the east. We've got oak wilt, and those diseases are taking out a lot of susceptible oaks. The good news is that all of the oak populations that have been studied, which is most of them, have resistance to these diseases in those populations. There are susceptible trees. They're going to get sick. They're going to die. You can spend a lot of money trying to save them, but it probably won't work. What we need to do is expand the resistant genotypes. And the jays are helping because before they move an acorn, they pick it up and they weigh it. And they only move the heaviest acorns. And those are the ones produced by the resistant trees. A smaller acorn by a sick tree is going to be rejected by the jay. So they're moving around the resistant varieties. I hear arborists say, don't plant any oaks, they're going to get sick. I say just the opposite. Plant as many oaks as possible, and the ones that don't get sick are going to be the future of our oaks. And by the way, it's decades before you see any sickness. So you've got a powerful tree in the ground. If oaks don't belong, now the farther north you go, the oak diversity decreases until it finally disappears, and that's when willows take over as the best keystone plant. Got a lot of species of native willows. Native prunus are very high. Birch is very high. The trees that belong in our forests are almost all keystone plants. So you do have a lot of options.
Good advice there. And just relating it to what they see out in the woods is probably a great way of looking at it. A lot of people talking
I'm going
about
to give you
deer.
one caveat.
Sure.
If you go in the woods and you're looking low, they're going to all be invasive plants. So I've been to nurseries and they say, "Hey, it's growing in the woods. It's native." No,
Yeah.
barberry, burning bush, not native just because they're growing in the woods. So
A lot of people talking about deer. And I know in your area it's probably the same thing, a lot of deer issues, that kind of thing. And yeah, one person asked, geez, should I still remove invasives if they're the only things that survive deer? Her property has no native shrubs or seedlings because of deer. And a lot of, another person, Joe, uh, has added natives for over 3 years to his northern Delaware home, but he's had extensive deer issues. How do I deal with this? Is what I'm being asked.
right, serious problem. And let's throw in Lyme disease with that because we've got
Hmm.
Lyme disease because we've got an overabundance of deer from coast to coast. One thing a lot of people don't realize is that one of the reasons, perhaps the major reason, that our invasive species are so invasive is because of the deer. The deer eat our natives and they don't eat the invasives. So what's left? It's the invasives. It's not that they're super plants. It's not that they deserve to be there. It's just that the deer don't like them, just like our insects don't like them. So the real solution is we've got to reduce deer populations. Now I know the single homeowner is not going to do that, although you can help by not opposing deer hunts. It's usually the homeowner that says, "Oh, I won't support that," and then it doesn't happen. Ern Blassie at Cornell is the only one who seems to be really serious about getting the deer population under control, and he recommends we move to market hunting for deer. Remember how successful market hunting was with the passenger pigeon and with bison and with Carolina parakeet? It works. Now, I'm not suggesting we hunt deer to extinction, but we've got to get them back down to the carrying capacity. They're about 10 times over the carrying capacity, the ability of the landscape to support them, which is why they're causing problems everywhere. To give into it, to say, well, let's leave all this invasives because it's the only green thing. Those invasives aren't doing what we need them to do. That's giving into the problem and not addressing it. We need to get serious about either put the predators back, so I'll support that. Put the wolves back, put the bears and the cougars back, or we have to become the predators ourselves. Those are the only options.
I have a question from Peter, who asks, will homeowners do more harm than good if they remove lawn for to plant natives, but in the process open up their landscapes to invasive plants? How would a homeowner prevent that kind of thing happening? Because let's face it, as you said, there's lots of invasives around, lots of seeds flying in. What would you say is the best way to prevent that?
I think the best way to prevent that is to do it slowly. Start small. Don't remove more lawn than you can replant and manage. You do have to monitor for invasions every year, but when they come in, they're small. They're very easy to control. If you have 50 acres, you're not going to remove 50 acres of lawn at the same time. So pick at it. The bigger the property, the more serious the invasive species problem is. But for a typical homeowner, that's usually not the major issue.
Yeah, so basically what you're saying, and it's sort of the same with anybody who's doing work at home, is that start small and keep working at it is what it's a process.
That's right.
That's what you're saying. Yeah.
Make it a hobby, and you'd be surprised what you get done in the next 10 years.
Yeah. Uh, the other question that was asked about deer was from Rob, and he's installed a garden, but wonders if there's a deer repellent that can be used. And what have you seen with deer repellents?
Yeah, there are deer repellents that work, but like there's mixtures of rotten eggs and coyote urine and all kinds of things, and it works pretty well. The problem is, many of them get washed off every time it rains, so you have to be out there with your squirt bottle religiously doing it. If you miss one, the deer will be right there. The other problem is, particularly if you're trying to restore a viable food web and you only have deer resistant plants or plants that you've sprayed, you're also eliminating the insects that need those plants as well. So it might keep the deer from eating them, and if there's just a period where you don't want that to happen, okay. But as a long-term solution, it's going to ruin your food web. When you change the odor of the plant, then the insects don't recognize it either. So if you had an oak tree and you sprayed it with deer repellent, it's no longer functioning like an oak tree.
So, and I know a lot of people are hearing this out there. Uh, Nancy, for instance, has asked about of native cultivars or nativars, which is a word that we hate. Um, but and American Beauties obviously looks at this and says, well, naturally occurring selections, things that are chance seedlings are are viable and important to use, but what do they bring value to the landscape in your mind? And is it important to be completely sequestered from using natural selections?
Well, so a variant is what you just said. It's a genetic variant that occurs in nature. Maybe it was selected for, like Phlox paniculated jenna was a variant found in the mountains of Tennessee. It has twice the flowers as the straight species, and it's got twice the pollinators. But of course, nature essentially created that. It was brought in, put a cultivar name on it, and people don't know the difference.
Mm,
Um, so a cultivar is a genetic variant of a plant, and it depends on what the genotype change, what the change in the genes was. So we did a study looking at 6 common cultivar traits for woody plants, taking a tall plant, making it short, introducing disease resistance, enhancing berry size, things like that. And the only trait that discouraged insect use was taking a green leaf and making it red or purple, because that introduces anthocyanins into the leaf, which are feeding deterrents. So that's the only blanket statement I can say in terms of our experiments is avoid red leaf cultivars if you're trying to help the food web. If you're trying to help pollinators, double flowers aren't going to do it because you've taken
yeah.
the reproductive parts of the flower and turned them into petals. They're beautiful. Most of our hydrangeas are double flowers, so they're not really helping the pollinators. Um, but the other cultivar traits, many of them are just fine. I will mention that Mount Cuba Center has been doing a lot of trial gardens with various cultivars, and they have all of the results up on their website. So if you're interested in a particular cultivar, chances are they've looked at it in terms of pollinators. You can go to the website and see what it is. Mount Cuba Center in Hockessin, Delaware, good for plants in the east. But there's no, the answer is it depends on what the genetic trait was that created the cultivar, whether
Mm.
it's going to be that useful or not.
And as always, people that are doing intentional breeding in a lot of ways are the things to avoid. And though, as you said, a lot of those cultivars, those names, people look at a name and there's no distinction about whether it was found
Right.
natural and open pollinated or that somebody actually did the work. So there's uh, I mean I'll put in an AB plug, an American Beauties plug here. We do not want hybridized plants in our brand and are looking at those open pollinated selections, many of which have great stories as you've alluded to. Um, a further question, what Michael asks, what is your stance on bird feeders? Sounds like you do feed birds, but uh, tell me what your thoughts are on that.
Yeah, I do. I've heard ornithologists, although not recently, but I've heard them say, "Oh, you don't have to feed the birds. There's plenty of food out there." I don't know where they live, but there sure isn't plenty of food in the neighborhoods where I live.
Hmm.
They're just barren landscapes. The birds that winter here become granivores. They're eating seeds, and there used to be a lot of eastern meadows, eastern prairie plants. The landscape in the last several thousand years was much more savanna-like, where you had big trees, but you had a lot of flowering plants under those trees. That is all gone. Most of our meadows were converted to agriculture, so there really is not enough seed out there for healthy bird populations. Studies have shown when you feed the birds over the wintertime, they enter the breeding season heavier and they lay more eggs. Now you have to do it with bird diseases in mind. You don't want to crowd your feeders so that a sick bird can transmit diseases. I've never had problems with that. I don't feed the birds in the summertime when it starts getting warm because then the seed can go rancid. Um, Birds will still use it, but I do it, starting in end of September really, and then through probably end of April, and then I stop. But I do know some people that feed all summer long, and their birds seem to be happy. So, but anyway, I support it. It's good for our poor birds.
And we'll get you one final question here. Thank you for being so patient. Um, it's talking about leaf fall. Should we leave the plant? Should we leave leaves? That's an interesting way of looking at it. Should we leave leaves where they fall, or should we shred them for composting? And if you say to remove leaves and plant debris, when should that be done?
Okay. All of these land management things work together. I am suggesting we have less lawn, but the lawn you keep, you got to remove the leaves from it. It's not going to help the lawn. So you want that lawn to that's your advertisement that you understand what the culture is. It's a cue for care. You're going to mow it. It's going to be pretty. You don't have to fertilize or anything. It'll be fine without that. But you do have to rake the leaves off of it. Where are you going to put those leaves? You're going to put them in those expanded flower beds under your trees that go right out to the drip line. Now, not 5 feet thick, because that will suffocate the plants that want to come up. But our native plants are much better at getting through leaf litter than we give them credit for. Nobody was raking the leaves in the old days, and we had native plants in North America. So put your leaves in your flower beds um, and plant right through it. So that creates that soft landing, that wonderful material for our caterpillars to complete their development in. Shredding them. There was an interesting, I went to, where'd I go? Buffalo. And somebody at the university there did a study. They got the bags of leaves from the curd that people had raked up and put in the bags, brought them back to the lab, and then they had a bunch of undergrads go through the bags and see what was in those bags. And I don't remember the exact number, but it was dozens of species of insects alive in the bag that you were grinding up when you mowed them. You're grinding up that Luna moth cocoon. You're grinding up all kinds of wildlife that is down in the litter. You're grinding up your firefly larvae. They are predators in leaf litter. So yeah, it keeps the leaves. Maybe it makes them a little bit more aesthetically pleasing, but they don't last as long either. If you have leaf litter that doesn't make it through the season, then you've got bare soil, and you got to go buy bark wood chips or something. Um, so extend the life of your leaf litter. Have it thick enough so it can make it through the season. Your plants will grow up through it just fine.
Well, on that note, Doug, this was a fantastic hour and 15 minutes that you presented to us. Great information. All of us at American Beauties, thank you for doing this and for having that great message out there that we all can follow. So, thank you so much, Doug. Appreciate it.
You are welcome. Goodbye, everybody.